All right, hello class. Today what we're going to be doing is talking about the lesson 1, Introduction to the Atmosphere, in the Atmosphere and Climate unit. What you'll need to do first is you'll need to put your name, your period, and also your due date in the top right-hand corner. What we'll do first is go over lesson 1, Introduction to Atmosphere. Okay, and what I want to do first is point out the main focus of lesson 1. In this case, the main focus is to develop a basic understanding, of characteristics of the atmosphere, and the process of atmospheric heating / energy transfer. Okay, so those are some of the topics that we're going to cover. Now, if we take a look at section number 1, okay, over here, section 1 is the characteristic of the atmosphere, characteristics of the atmosphere. Now, this can be found on pages 4 through 9 in your textbook, so pages 4 through 9. Okay, this is in your Holt textbook. First thing that I'd like to do is go over atmosphere. So obviously, many of you know that the atmosphere is a mixture of gases which surrounds the Earth. So a mixture of gases that surround the Earth. Okay, so I'm sure many of you have heard of the term atmosphere or used it before. Now, if we take a look at the composition of the Earth's atmosphere, okay, composition, we're going to find that there's different gases that make it up, okay? And in this case, we're going to take a look at nitrogen and oxygen, the two major components of the atmosphere. Now, in this case, nitrogen makes up 78% of the Earth's atmosphere, okay? Oxygen only makes up 21%, which is still more than some of these other trace gases. So when we're trying to look at the different sources, we can find that nitrogen it comes from the decomposition of plants and animals. So I'm going to abbreviate this. So decomp of plants / animals. Okay? So that's number 1. The second one is volcanic eruptions, okay? So that's the second way that nitrogen is released into the atmosphere. So volcanic eruptions. These are the two major processes. Okay? So we have number 1 and we have number 2. So now we need to look at oxygen, which makes up 21% of the Earth's atmosphere. In this case, it's a product of photosynthesis, okay, in plants and phytoplankton. Phytoplankton are microorganisms in large bodies of water, like the ocean. So I'll write that down. Photosynthesis. Product, so a product of photosynthesis from plants / phytoplankton. And phytoplankton, that's what, okay, that's a far right one. Now the trace gases that make up the atmosphere include water vapor, carbon dioxide, and argon, okay? So water vapor, carbon dioxide, and argon, a noble gas. These are trace elements that are found in our atmosphere. Okay, trace gases. So, what is the effect of this composition? Well, what we'll do is quickly point this out. The effect of the composition. So now if we take a look at air pressure, okay, air pressure is the measure of the force with which air molecules push on the surface. So the gases affect the air pressure, okay? So I'll write for air pressure, we'll write measure of the force with which air molecules push on a surface. With which air molecules push on a surface. Okay? So that is air pressure. Now the effect of air pressure. Well, in this case, if we're looking at Stevens Point, which is close to sea level, there's 15 pounds of force per inch squared applied to our bodies. So 15 pounds of force per inch squared. Okay? That is the effect of air pressure, especially on our bodies. So as altitude, the height above sea level increases, the pressure decreases. So altitude, height above sea level, increased height, height above sea level. Okay, so as that increases, then the pressure will then decrease. So as we move up in altitude, the pressure decreases. Okay? And this has to do with the air particles. Okay? There's less air particles that are pushing down on us. The density of gases also affect the temperature, which is a direct relationship. So affect temperature. Okay? And then what we'll write here is direct relationship. Direct relationship. Now, how is this a direct relationship? Well, as the density of the particles increases, so density increases, the temperature will also increase, okay? There's more interactions between the particles. Okay, so the density of gases also affects the temperature. So what we need to do next is move on. What I'd like to do is show this quick visual here. It's the composition of the atmosphere. Nitrogen makes up 78%, as you can see in the pie chart here. Okay, and then oxygen makes up 21%, the second component. And then this 1% here is the remaining 1% of carbon dioxide, water, vapor, and other gases. You can find that in your textbook. So the layers of the atmosphere, let's take a look at this. We take a look at the layers of the atmosphere. We'll start out with the troposphere. Okay, the troposphere is the layer in which we live in, the one that is the nearest to Earth. So we will write layer in which we live, okay, and contains 90% of the total mass of the atmosphere, okay? Now, that's because it's very dense near the surface, okay? More particles being pushed down and forced together. Okay, so that is the troposphere, the area in which we live in. Now, when we're talking about the stratosphere, this is the next one here, stratosphere. Okay, this is the next layer up. This layer is made up of layered gases that don't mix and is very cold. The average temp is around -60 degrees Celsius. Okay, Now, so for this one, what we will write is the layer made up. So layer made up of layered gases that don't mix and is very cold. And is very cold. Okay, so this layer is quite cold. Okay, now like I said before, the low stratosphere is extremely cold, and the temperatures are averages around -60 degrees Celsius. So if we take a look at the ozone layer, this protects life on Earth by reflecting harmful ultraviolet radiation, or UV radiation. Okay, so protects life on Earth by reflecting harmful UV radiation, okay, ultraviolet radiation. Okay, so that is the ozone layer. Obviously, the ozone layer, as you can see here, is inside of the stratosphere. Okay, we can also mark that as O3. Some of you may have seen this before. The ozone layer, O3. Okay. Now the mesosphere. We take a look at the mesosphere here. This is the middle layer of the atmosphere, and it is the coldest layer at -93 degrees Celsius. So the density of the gases are low here, and that means that it's going to be colder. So what I'm going to write for this one is middle layer. Okay, so this is the middle layer, and it is the coldest layer. Okay, this is the coldest layer. Right here we have -93 degrees Celsius. It's very cold. Okay, and like I said before, it's because the densities of the gases are lower here. Okay. Now if we move one layer up, we're going to move into the thermosphere. Okay, the thermosphere is the uppermost level of the atmosphere, and if we take a look, temperature versus altitude is inverse at this layer. So in this case, this is the uppermost level. Okay. So in this case, what I would like to write is the fact that the temperature versus the altitude at this point is inverse. Now, the reason why this relates to this is because there's few particles and there's few impacts where heat can be transferred very well. Okay, so that is the thermosphere. Now, the thermosphere is also receiving quite a bit of radiation, all right? Solar radiation from the sun. And this is the reason why we have high temperatures, okay? And there is a fast motion of particles. So higher temperature is going to be the result of fast particle motion. Fast particle motion. Okay, and with low heat, we have low density and few impacts. Okay, so like I said before, the fewer the particles, the fewer the impacts, and heat cannot be transferred very well. So with low heat, we're going to have low density and fewer impacts. Low density and few impacts. Okay. Now the ionosphere, this is the uppermost portion of the thermosphere. Okay. It's located in the upper mesosphere. Oh, I take that back. It's the lower thermosphere. It's located in the upper mesosphere, okay, in the lower thermosphere. And I will be able to show you that in a minute here. This is where there's electrically charged particles, and this forms the auroras that we have seen before. These are also known as the northern lights. Okay, so the ionosphere is located in upper mesosphere and lower thermosphere. Okay, so the mesosphere is a layer below the thermosphere, so it's at that interface. And this is where the electrically charged particles are located. Okay. Charged particles. Now these charged particles are coming from the sun, the incoming solar radiation. And they're creating the auroras that we see. Now these auroras, this is light energy radiated from ionized gases. These are from the sun and they're being radiated, or known as charged particles or charged gases. So when we're talking about ionized gases, we're talking about charged gases. So light energy radiated from ionized gases. Okay, so what we can do next is I'll show you an image of the layers of the atmosphere. If you take a look up here, you'll be able to see that we can start in the lowest part of the atmosphere, which is the troposphere, where we live. Okay, this is where life exists. And then we move up to the stratosphere. We'll be able to see that in the stratosphere, as we move up, the temperature begins to increase, so there's an inverse relationship there. Also, when we move into the mesosphere, we'll be able to see that at the interface between the stratosphere and the mesosphere is the ozone layer. We talked about that protecting human life from UV radiation. And then at top is the thermosphere, where we have charged particles that form the auroras that we see. Okay, so these are the charged particles. And if you look in your book, you'll be able to see at times there's inverse relationship between the temperature and the altitude, okay? As we are in the thermosphere, the temperature is increasing as we increase altitude. Okay, so we'll move on to the next portion. Section 2 is atmospheric heating, chapter 1.2. You can find this on pages 10 to 13. So pages 10 to 13. This is in your whole textbook. Okay, energy transfer in the atmosphere is the first thing that we're going to go over. If we take a look at radiation, this might be review. Radiation is the transfer of energy via electromagnetic waves. Transfer of energy, E, I'll abbreviate that, via electromagnetic Okay, so this is one method of energy transfer in our atmosphere. Now, something that's important to point out, I'll put this in red here. You'll be able to see that the sun, only 2 billionths of the sun's energy actually reaches Earth, but that powers all of our living organisms. Okay, so the sun, so 2 billionths of energy reaches Earth. So from all the energy that's created by the sun, only 2/1000ths of it actually reaches Earth. Okay. So next thing moving on is thermal conduction. This is another method of heat transfer or energy transfer. What we'll see here is that the transfer of thermal energy through materials. This is conduction. So energy from the Earth is transferred to the atmosphere via direct contact. The most important point about this is that it's via direct contact. So transfer of thermal energy or heat energy, I'll abbreviate that, through materials okay, and then energy from the Earth is transferred to the atmosphere via direct contact. Direct contact. Okay, so what we can point out with this is that when the particles come into direct contact with the Earth's surface, this is able to drive the Earth's weather and climate. Okay, so this is direct contact. We're taking a look at convection. You might be familiar with convection currents. We'll go over that in a minute. Convection is basically another method of energy transfer in which there's a circular motion, okay, of a liquid or a gas. So it's the transfer of thermal energy through the circulation of a liquid or gas. Of thermal energy through circulation of a liquid or gas. It's important that this occurs in a liquid or gas. So this does happen in our atmosphere, okay? We can see convection currents that are able to drive weather. Okay, so the warm air rises and the cold air sinks. So convection current is the circular motion of warm air rising, so warm rises, and cold sinks. And in this case, we're more focusing on the atmosphere, so you can think of the gases in the atmosphere doing this. Okay, this is going to power our weather. Now, when we look at the greenhouse effect, okay, the greenhouse effect is something you may have heard of before. This is the process by which greenhouse gases like carbon dioxide and water vapor absorb the thermal energy from the sun and radiate it back to the Earth. Okay, so the greenhouse effect is the process by which greenhouse gases, and some example of these are going to be carbon dioxide and water vapor. So carbon dioxide and water vapor okay, carbon dioxide and water vapor are going to absorb thermal energy from the sun and radiate it back to the Earth. Absorb thermal energy from the sun and radiate it back to Earth. Back to Earth. Okay? So you could think about the greenhouse effect being similar to being in a hot car, or in a car on a very sunny day. What happens is that radiation from the sun is able to travel through the glass or the windshield of your car, and then it hits the seats and it's reflected back as long-wave thermal radiation and is trapped in your car. Causes your car to be warm. Okay, so radiation balance. We can think of the balance between incoming energy or solar energy and the outgoing energy or thermal energy. So radiation balance is balance between, I'll abbreviate that, incoming energy or solar energy, incoming solar energy, and outgoing thermal energy. Thermal and like we had talked before, that solar energy enters into our atmosphere, okay, and then our greenhouse gases are going to trap the thermal energy, making our Earth warmer. Okay, it's very important. It keeps our planet at a stable temperature, so the greenhouse effect is important. Now we take a look at global warming. Some of you have probably heard this before. Global warming, there's many hypotheses about global warming, but it does occur. Global warming is the fact that over the course of the past 100 years, so the fact that over the past 100 years, the average global temperature, the average, I'll abbreviate that, global temperature has been continually rising. Has been continually rising. Okay, now we look at the hypothesis as to why this is, and we can relate this to the greenhouse effect. The more greenhouse gases that are put into our atmosphere, it is believed that we are not able to release some of that thermal energy. So we take a look at the hypothesis for this, and what we'll write for this portion is human activities like burning fossil fuels and deforestation, burning fossil fuels and deforestation So burning fossil fuels is going to put more CO2 into the atmosphere. Has increased the amount of carbon dioxide or CO2 in the atmosphere. Okay, carbon dioxide is a greenhouse gas in the atmosphere. And this increasing the amount of energy absorbed. So this increases the amount of energy absorbed. So increases amount of energy absorbed. Okay. So that is why that is a problem. We're not able to release that energy because of the extra greenhouse gases in our atmosphere. So that is all that we have for this recording. This was Lesson 1, Introduction to Atmosphere.